Hello, I'm Hunter Broadway. I'm here with,
Mr. Gregory.
and we're going to talk about 3D printing today. So, we have a 3D printing class at school, right?
Yes.
Alright. So, explain the basic concept of 3D printing.
Okay. Well, generally, before in manufacturing, like with Mr. Hofer's class in wood shop, you usually take a piece of material and you subtract from it. So you're taking a piece of wood and you're cutting it down and getting it to the size you need and putting it together. Well, 3D printing is also known as additive manufacturing. And additive manufacturing is kind of the opposite of subtractive manufacturing. So instead of subtracting material, we're adding material. So ultimately, most of the 3D printers that you see today, that you will use, that we have at the school, most of them are called what's a fused deposition. They use material and they melt it, and as they melt it, it forms little lines, and they put it down and they add the material that way, and they put layer upon layer upon layer. So it's like Lego blocks in a way. They just keep putting Lego blocks down and they keep adding layer to layer. So that's kind of the general concept of what 3D printing is, or additive manufacturing, you may hear it called.
Alright. How would you think 3D printing will affect the future?
Most businesses today are using 3D printing. 3D printing got its start from what's called as a rapid prototyping, because it was so quick to make a part. Then I could come in and say, well, this is what you're going to get. And we could make this within a day. Most things that are made like on a CNC machine, which is a computer numerical control. Those machines can take very long times to program. So I couldn't come in and say, well, let me show you what you're going to get. It would not take weeks or months to show that. Or where 3D printing came in with this rapid prototyping is to quickly come in and say, well, here's what you're going to get. And you could say, well, I need 10,000 of those. Well, then we could go to a CNC machine and start to produce those and make the code. Once we got the code made, the CNC machine is going to produce those over and over and over and fairly rapidly. It's the time to produce the code. So that's where 3D printing came in rapid prototyping. So even today, rapid prototyping is 3D printing is still very important for rapid prototyping. We can produce things very quickly. It might seem like it's something that I print and you're like, oh, that took a day to print. And there's different time variables of why certain things take longer. I can make it take shorter, longer, but things change depending on how I want things to look. But you might like, that took a day? Well, that took a day for this. But like I said, on a CNC machine, this might have taken a month to program it all. So one of the reasons is things like that. So because of rapid prototyping. So many businesses use them today so they can get examples of items and have a copy of something there right away. The other thing is we're starting to use more and more materials. It used to be plastic. Now they're starting to use metals and composites in 3D printing. So even like aircraft engine blades being made out of metal are 3D printed. And there's different techniques to do it. And so companies are finding that it's much more cost prohibitive. For one, unlike subtractive manufacturing, where you're taking a piece and you're cutting the pieces of it off, you're kind of throwing that scrap away. In additive manufacturing, you're just putting down what you need, and it's less wasteful. We can customize things. I mentioned before that I have this, pull it out here. I have a pencil sharpener. All right, Hunt Boston model number 18. This thing's like 50 years old. Okay, it will sharpen a pencil, and I can do eye surgery on you with that pencil. It's so sharp. All right, it broke one time on me, and I was devastated when it broke. When I opened it up and found out, well, it had an old gear inside of it, and that gear just got brittle. Well, I went on, and I actually found someone at first, and they reproduced this gear, and I printed it myself, and I put it back in there, and the thing works great. I ended up buying a couple more of these because I realized that most people were selling these because the gears were broken. They didn't realize how to fix it. So I was buying them. I bought this one here, and the little drawer that holds the shavings was broke. I went in, produced my own little drawer. It's good. This one here is as good as new. So customization. You can make parts that fit you to work for what you need to work for. I tell people that sometimes most people have a printer in their home now that will on paper, you know, so you can print your homework or print stuff like that. In another 20 years, people may have 3D printers in their home much more often, where they come in and they say, well, you know, I need this for this part for this, and they can just go in and print it themselves instead of going to the store. So that's kind of the future of things a little bit.
Alright, so in your class, what kind of things do you print in class?
Well, if you take my, I have what's called Engineering Designs 1, 2, and 3. In Engineering Designs 1 and 2, we actually learn to do drawings that are like this. So those are two-dimensional. Okay, it's kind of like blueprints.
Yeah.
Right? It's a very, it's a class that's used in a lot of professions out in life. So if you're going into architecture or into design, so designing things, products, if you're going to be into interior design, telling someone, hey, I can show you what the inside of your house is going to look like if we're going to redo your kitchen. You can do outside landscape architecture, so someone could come in and say, hey, I'm going to redo your patio or your bushes around your house, and we're going to show you what it's going to look like. Well, that's where CAD systems come in that we use in my engineering design classes. These are 2D prints, so we do things like manufacturing, but they also do like game design. If you're in game design or movies, they like these new superhero movies, they use CAD systems to help do the animation. So the stuff I do at first, the first two parts, as I mentioned, is two-dimensional, but when you get to part 3, we start doing what's three-dimensional. So then we start taking this two-dimensional design and we start giving it some depth. And that class is in the end is where we can start using the 3D printer. So that's one of the classes I teach. The other one is manufacturing processes, and we talk about some of the different ways that you can take materials and manufacture them, and one way being additive manufacturing in 3D printers.
Okay.
So some of the things that, you know, if you took the manufacturing process class, we would learn more about the different types of 3D printers that there are in the world. Like I said, some of the ones that we use are that most schools use is they'll take a filament, a plastic filament, they heat it up, and it produces a line wherever it's supposed to print, goes down a layer and adds on. There are other ones that use layers of almost looks like a fine powder, and when a laser or a water, depending on what type it is, hits that, like the laser hits that powder turns solid. And when they're done, they can pick it up. Anything that wasn't hit by a laser would just fall off to the side and can be reused. Anything that was hit by a laser turns out to be your product.
That's pretty cool. Would you like to show us how to print something?
Sure. I can tell you the first step in any printing is anytime you're working in print it's going back to my engineering design course. It has to be drawn first. Mm-hmm. That's the first step of anything when you go to print. I can show you how we're going to draw something first, and then we can look about how we can take that and turn it into an object, print it.
Sure.